Hello everyone, welcome to a new episode of Golang Cafe, and today we are going to talk about pointers. So pointers, a very interesting topic, and not a lot of languages, not a lot of high-level languages have pointers. So it is truly something that a lot of people are not familiar with. Some of you may already been familiar with pointers if you have worked with C or C++ before. So if you are not, then this episode is for you. You can see how pointers fit within Go and what they use for. Before we get going with pointers, we should go through how memory works, because this is fundamental to the functioning of pointers and why pointers exist in the first place. This is just an example of how the RAM is structured. So we can just get started to see how the RAM is structured just in a very small representation of it. Here you can see. So this is how the RAM is organized. You can think of it as two different entities. So you have cells and addresses, and you have a hell lot of them. So you have a lot of cells, and each cell is identified by an address. So the cell is where the values are stored. So the value of your program is stored. So whenever you declare a variable and then you assign a value to it, then the value is stored inside the cell, inside that cell that you can see here. And each cell has an address, and in this case it's just an hexadecimal address, and the length of this. And just a nice thing to know is that the length of this address is defined by your architecture. So if you're in 32-bit architecture, then you have 32-bit address. So you can address up to 32 minus 1 memory addresses, which each one of them is going to be 1 byte. So each cell is going to have 8 bits. And you can obviously represent different data in there as binary data, and then the Go runtime will decode that into whatever whatever type or whatever variable you have defined. So let's say that this is the RAM. You have cells, and each cell has an address, and each cell is 1 byte, so 8 bit. And let's say, for the sake of this example, that you define 2 variables and then 3 variables, because you do the sum of A and B. A is equal to 10, B is equal to 20, and then you define the C, which is the sum of the 2 variables. And you have three variables. At this point, what happens in RAM? Let's say that A, B, and C are all integers, 8-bit integers, so A, B, and C. And the reason why I say 8-bit integers is because then they fit exactly within a cell. So it's very easy for this example. It's actually more realistic as a representation. So let's say that A is the first cell, allocation 0, 0, and we set it as 10. And then B is location 0, 1, and we set it at 20. And then we create C, and it's A plus B, which is 10 plus 20, which is 30. So, and this is basically the RAM, how it will look like once you arrive at line 39. So your program executes, you arrive at line 39, and what happens is basically, actually line 37, you would have A inside this cell, and then B inside this cell, and then C, line 39, you would have C as a result, and you would have the memory address of C, and you have to have the value of C as 30. You don't normally actually, like if you don't use pointers, you don't normally work at all with memory addresses. In this case, you don't see the memory address of any of those variables. You don't know that A in this example is 0, 0, or this is 1, or this is 2. So you don't actually know it if you don't actually go and print the value of the memory address. There is a way for printing the value of the memory address. Printf main, I say main because the main function main.go, and then we say for example here address %p, which is used for using the printing the memory address, and then the value v. So we say and now it comes the actual pointers operators. So you have the Go pointers, and you have a bunch of operators that you have to learn when you use Go pointers. So Go pointers have two specific characteristics. The first one, is something that characterizes pointers. It is that exclusively, so it's clear. It is that variable that is used for storing pointers exclusively contains, and is used for exclusively storing memory address of another variable. So when you define a Go pointer, the value of the Go pointer, it is a memory address. So it will be 0x00, 00, 0x01, or 0x02, and so on and so forth. It will be either one of those values if you define a Go pointer. And there is another gotcha as well with Go pointers, because you could say I want to store I want a Go pointer that 0x23 or something random that you want, right? But you cannot actually do that. So Go pointers are defined for a specific type. And that's when you need to just refresh the Go types. So you have Boolean, integer, different type of integers based on how large they are, string, byte, and all of that. And then you also have more complex types like structs, maps, and all the other types. So the pointer is defined for an underlying Go type, and it is exclusively used to store the memory address of another variable. You cannot use the pointer to store a string or a number or any other thing. It's just used to store the memory address of another variable. So those are the two main characteristics of the Go pointers. Now we will see how we declare the Go pointers. So how do we declare the Go pointers? Let's just declare our first Go pointer. So the first Go pointer that we declare is p, and we just declare it like this. So we use the star, and then we say which type we want this pointer to be for. So star t as a meta example, and in this case I just want it to be a pointer to int. So p will contain a memory address for any integer variable. Okay, and this is how you define the Go pointer using the star sign, and then you append the type for which the pointer is valid for. Obviously you can define this for any other types like float 64, or you can define for Boolean, or for a map, or for a struct. So it is really up to you how you want to, what type you want to associate with it. And once you know how to declare the pointer, and once you know the two characteristics, that it's exclusively used for storing memory address, and it is defined for a specific Go type. Once you know those two characteristics, then there are two new operators that you may not know, that you may have used but you're not really understood. And those two operators are the addressing operator, which is the ampersand sign. So let's just remove this because it's confusing. So this is ampersand sign, and what it does, it takes the memory address of a variable. So you have the ampersand sign, and then you have your variable here. So you say, okay, I want the memory address of A, and that returns the memory address of A. And then you have the dereferencing operator, which is the opposite of the addressing operator, and it retrieves the variable by using its memory address. So if you, and it's used, it's usually used on pointers because because it's basically retrieving the variable that is stored in that memory address. And this is where the confusion comes in for me as well, because you use a start sign, and the start sign is also used for defining pointers. So the dereferencing operator is also used for pointer definition, which is, in my opinion, it is a bit misleading. Not misleading, it's a bit confusing. But effectively, from a syntax point of view, if you look at the syntax tree, from a syntax point of view, the pointer definition, declaration is done using start t, and the pointer dereferencing is using pointer and then the variable that you wanted to reference. So the declaration is a different thing than the dereferencing. So when you want to declare it, or when you want to put in your function signatures, you use the star and then the pointer type, and then when you want to retrieve the actual variable that is behind that memory address, then you also use the star sign, but it has different meaning depending on where you're using it. So you just need to be careful of that and mindful of that. And yeah, you just need to be mindful of the two different operators, the main two operators of point, which is addressing and dereferencing. So if you want to find out, for example, what is the memory address of A, you just use the ampersand sign, as we have done here already, and this returns the memory address, and you can print it. And if you have a pointer value, if you want to look at the actual contents of the cell at that memory address, then you use the dereferencing operator, which is the star sign as well. So let's start first with the printing the value of the pointer, which is straightforward. So 36, so we have to remove a bunch of things here. Okay. C declare, right, this just was for the example. So here you have the memory address of A, as you can see is a 0x and all these numbers here, and then you have the actual value, which is 10. So let's now work with the pointer of A. So we said we want to declare the pointer of A, so you have two ways. Either you actually declare it as explicitly, or you can use automatic inference, and this will be used by using the addressing operator. So now P is a pointer to A, and we can use the dereferencing operator. So we first print this, and then what we do, we can use the dereferencing operator. In this operation, with this operation, we can now access A directly, and we can modify the value of A. So now from 10 it can become 20. So we can select this, copy, and paste it. So what we have done here with the dereferencing operator, we say P contains the actual memory address of A. So P address is gonna be something like 0. It's gonna be like 0x2, 0x01. So A address is gonna be 0x01, and the value is gonna be 10. P address is gonna be 0x02, and the value is gonna be 0x01, because the value, remember that the value of the pointer is always going to be a memory address. The dereferencing operator, what it does, it says go to this memory address and retrieve this variable here. So effectively just goes into this cell location here and retrieves the value of A. And then here we are overriding. So we can either read, or you can read the value of a pointer, the variable that the pointer is pointing to, or we can override it. In this case, we are overriding it. So let's see what happens now. So it should be overridden. As you can see, now we have 10, and then the second example is 20. So let's just add just a new line. And you know, as an example, and to make you aware as well, you can also use you know, this is exactly the equivalent. So if you have address of A or P is exactly the same thing, because you know, both is going to be 0x01 in this, you know, like as an example here it's going to be a longer number, but it is, you know, like assume that it's 0x01. There's going to be 0x01 either if you use P or if you use address of A, exactly the same thing. And the same thing goes for this. So the variable A, so the actual content of the variable A is 10 here, and is as well as 10 here, because the dereferencing of P says, okay, just take me to the variable at this memory address, and that's going to be A. So this will yield the same result. As you can see. So yeah, this is a very basic example, and now we can see how this fits within the function, and the function in this case just want to change a number using the pointer to int. So here we have pointer to a number, we have pointer to int. We dereference it, so we say go to the variable at this memory address and set it to 42, and then it returns. So as you see, it doesn't actually return any value. So this should update the function, the value, change number. And this will be address, we need to pass a pointer, so we can either do address of A, which is going to be a pointer, or we can do P, which is the same thing. So as you see now, it's been updated to 42. Okay. So this is, you know, as straightforward as it seems. You just need to get used to the addressing and the referencing operators. But effectively, the pointer is just a way to manage different variables by using their memory location, as you can see from the example in the RAM example here up here. And now I just want to go through an example for the structs, because as I said, you can define pointers for integers, but you can also define pointers to struct as well. So here we have a person struct that has a name field, and I call it Joe. So let's just update this. So Joe is addressed as 0x01 for the sake of this example, and the value is Joe. Okay, and then I do change name to Joe, and I need to update the pointer. So and then I want to declare a pointer to a person. How do I do that? You can do either way. You can do, again, you can do var of var p and then pointer to person. This is a way, and then p equal address of Joe, or you can just do it with automatic inference, and you will understand it is a pointer to person. So it's a p equal address to Joe. And this is exactly the same thing. So, and then we do the change name operation. So the p address is going to be something we don't know. It's going to be 0x02, probably adjacent to the address of Joe. And the value is going to be the address of Joe, which is, as you can see here, 0x01. And the change name, we pass the p to the change name function, which is pointer to person here. We're just going to see in a second. So here we have p, here we have a pointer. We have p, which is a pointer to Joe, and then we have Joe. Just revert it back to Joe. Okay, and then we go to the, just ignore this for now. And we go to the change name, change name function takes a pointer to person, which you know, for simplicity, pointer to person, which is a p, which is a pointer to person, and we want to change the name of the variable that is stored at that memory location, which is the value of p. So how do we do that? We do again with the referencing, which is retrieves the variable by using its memory address. So p is a memory address again because it's a pointer with the reference p, so we get the variable stored at the memory address of p, and we set the name field to be Bob. So before it's Joe and then becomes Bob. And as you can see here, we are using this notation. So we are basically the referencing, and then you're obviously using the brackets, you know, to delimit the operation of the referencing, and then accessing the name. And then there is an important gotcha here to remember, which is that these structs, when you access structs field, when you access fields to pointer to structs, that the referencing is done automatically by the Go compiler. So here you don't need to, you know, it is a syntactic sugar, you don't need to dereference manually the struct to access a field, to change or read a field. It's done automatically. So this should yield the same result as well, Joe and Bob, as you can see. Okay, and you know, this is changing the name using the pointer. And then we had another example, which is change person. Let's say that I want to change the person entirely. Okay, I just want to change the name. Let's say that you know, maybe it's a very big struct, or I need to replace all the fields, and I call this Jane. Okay, I call Jane, and it's an address to person. It's, you know, takes the address of person, which is a pointer to person. Okay, so it's name Jane, and then p is gonna be equal to Jane, because p is a pointer and Jane it is a pointer as well, so we need to match the types. And we also need to change the change name to change person, change person. So let's see what happens here. So we get Joe and Joe, so this doesn't actually change. And the reason why it doesn't actually change, here we haven't changed anything, we just changed the function name. So when we get into the change person, it's not the address, remember it's not the address is not being passed, it's just the value that is passed. And that's another important thing of Go, another important gotcha is that in Go you don't have pass by reference, you always have pass by value. So this is a very, very important thing to remember, because in, you know, in other languages you may have, like in Go, in C or C++, you can pass value by reference. But in Go everything is passed by value. And a pointer is a value itself as well. So you pass the value, which in itself it is a memory address, but you don't pass the pointer. This to say that you cannot change the pointer directly. So what happens here when you do the change person, if we just go, we just do the same mental model here. So what happens is p is gonna have address, it's gonna be different, 0x03 for example, or 0x0, like 0x005, because it's another function and maybe it's you know, it's far away in memory from the main function. And the value is gonna be what we just passed, so 0x01. And our objective is basically to change what it is in 0x01. So the only way that we can do that is by using the referencing on this variable here. We cannot just set Jane, because now p it is a 0x05, which is not defined anywhere in the main function. So we just basically have a new variable, which is only defined and valid within the change person function, and we define as well a Jane, which has maybe 0x06, and value Jane. Sorry, value is gonna be address to a person, so it's gonna be yeah, it's gonna be another address to the actual value of Jane, 0x07, and then this is a temporary variable address 0x07, and the value is gonna be Jane. So it gets pretty complicated at this point, because then P address of P is still 0x05. The value that before was 01 gets overridden with 0x06, and we just basically now we just throw everything away, because once the function returns, we are now modifying the golden value, which is this. So our objective is to modify 0x01, but we're just creating new variables here. We're creating a new Jane. We create a new Jane, and we are basically overriding the pointer to person variable here with this new Jane. But then we're just throwing everything away, because this is not then reflected within the main function. And the way to do that, so the way to actually fix this issue, is by basically saying, I want to modify 0x01, so I want to dereference, I want to go to the variable contained at this memory address, and then update that value there. So the way I do that, I basically dereference, I go to the value of P, and then I assign Jane, which in this case, instead of being an address, a pointer to person, is just gonna be a simple type. So here Jane, we define Jane as a simple type. It was not like just using the temporary variable 0x06, for example, 6, for example. It's just random value. Then the value is Jane. Then we have the reference operation, and so we go, we set at the location, we set for the address 0x01, we set this value Jane, and then we return. So this is what the reference operation allows us to do. It allows us to go in a certain memory address defined by P, and we just assign Jane to that. We just assign the value that we want. So this should then allow us to change the value, as you can see. So Joe, and then I changed to Jane. And this is a very simple example of pointers. So it can be a bit fiddly, and it can be a bit complex to understand the first time, but you always need to bear in mind the very, very basic of it. So it's just all about having cell and addresses, and the two main characteristics of pointers is that they can exclusively store memory address, as you can see here, and those memory address are defined specifically for a specific for an underlying Go type. So it's not an arbitrary memory address. It is for a specific Go type, and this will allow you to basically operate with the pointers using the two different operators, which is addressing and the referencing. So the ampersand sign and the star sign. Well, I think that's all for today, and hope you learned something about pointers. I will definitely do other episodes about pointers, and hope you liked the episode. Thank you very much.